Alright, y'all, this will be a quick video, just about a little bit more some factoring examples. The key difference we're going to add today is we're going to have GCFs to pull out, greatest common factors. Not always, but you have to look for them. See, at this point we've put all of our factoring pieces together. We can factor by grouping, we can pull out GCFs, we have special cases like difference of squares. This is a square I'm drawing, difference of squares. And all these things can work together to make factoring a thing. So I'm going to look at this problem here, this equation. I want to factor it and solve it. Because it's equal to 0, I can solve. If it's not equal to 0, I can't solve, I can just factor. The first thing I always do when I'm factoring is I look to see if there's any common factor I can pull out of everything. And if the leading coefficient is negative, I always pull out a negative. So each of these terms can be divided by 2. So I'm going to factor out a negative 2. Now, I'm going to factor this piece in here. We'll remember our factoring by grouping steps. We multiply a and c, which is negative 8, and we write out all the factors of negative 8. I'm trying to find the pair that adds up to negative 7, and that's this one right here. So I had it right from the start. Now, people often get confused. This negative 2 is just going to hang out there. It's not going to do anything. Inside, I'm factoring this now. Inside here, I'm going to have 2x squared minus 8x plus 1x minus 4. Now I'm factoring by grouping with just this stuff inside the parentheses. The negative 2 just sits there and the 0 just sits there. So I cut this in half. I have negative 2. Out of this half here, I can pull out a 2x, leaving me with x minus 4. Out of this half here, I can just pull out a 1, leaving me with x minus 4. These combine. These combine. And the negative 2 is still there. So at this point, I have factored. Everything is written in factored terms as far as possible. And pulling out the negative 2 first is an important part of that. Now I want to solve. Okay, to solve, I take each of my factors and set them equal to 0. Solve and solve. We would have x equals negative 1/2 and x equals 4. So my solutions would be the set negative 1/2 and 4. That is factoring and solving by factoring out a GCF first. You should always look to see if there's a greatest common factor. Okay, it's always something you should look for because it can make the factoring a lot easier. Second one. On this one over here, I factored out a negative 2. If you have an equation, which I did last time and this time, you have the option instead of factoring, you can divide everything. Everything on the left side can be divided by 3, and my leading coefficient is negative, so I'm going to divide everything by negative 3. I think it's me x squared minus 100. Sorry, 4x squared minus 100 equals 0 still. Well, it turns out I can still factor. Like, there's still a GCF. Everything here can divide by 4. What that means is I actually could have started this problem by dividing everything by 12. I didn't see that right away. I see it now. I could divide by 3 and 4, so I could have divided by 12. Now I've got a difference of squares. This factors into x plus 5 times x minus 5, because x squared and 25 are both perfect squares. So my solutions are going to be plus or minus 5. Pretty sweet. Pretty bad check, but pretty sweet. By check, I mean check mark. Okay, so pull out a greatest common factor, and then factor. If you don't have an equation, you can't divide everything by the greatest common factor. So here, I can't divide everything by negative 3, but I can factor out the negative 3. And then from there, I would just keep on factoring the stuff inside. This factors into x plus... What does it factor into? I don't think it does factor. Two things that multiply to negative 4 and add to negative 5 don't exist. So this can't factor any further. I'm glad this happened here. It was going to happen eventually. It happened here by mistake, but I'm okay with it. So it can still factor. There's a GCF we can pull out. It can factor. It just can't factor further. That's as far as it goes. Okay? So, always be looking for a GCF. Always pull out a negative if your first term is negative. And then look for your special cases like difference of squares or binomial squared, or see if you can factor by grouping. Solve if you have an equation. Like I said, pretty quick. Thanks. See you next time.